Hi viewers, wishes of the day. My name is Jagdish Saikwar here. I'm here to explain about definite integrals. Let's see what is definite integral. Definite integral of a function f of x is denoted by integral a to b f of x dx, where a is lower limit, b is upper limit. Here, what is definite integral a to b f of x? We will look into that. Here we have an important concept that definite integral as the limit of a sum. How we define the definite integral as the limit of a sum? Let us look into that. Integral a to b f of x dx is the definition of limit n tends to infinity b minus a by n into f of a plus f of a plus h plus f of a plus 2h plus and so on plus f of a plus n minus 1h. So how we get this formula? Let us look into a small proof that say the function f of x here defined on the closed interval a comma b, where is f is continuous function. In order to find this formula, how we are going to prove that? Let us look into that. First of all, let us understand what is integral a to b f of x dx. Integral a to b f of x dx is the area bounded by the curve f of x is equal to a, x is equal to b, and above the x-axis. If we consider the curve in y is equal to f of x, x is equal to a, x is equal to b, and above the x-axis. Here we are assuming that function f of x takes all positive values, which is non-negative. Say, in order to find the area, the closed interval a to b, we are going to divide into n number of subintervals. N number of subintervals like this. In the graph, n number of subintervals in such a way that x0, x1, x1, x2, x2, x3, xn minus 1, xn, and so on, where x0 is equal to a, x1 is equal to a plus h. What is h? This is width of the interval x1, x1, x0, x1. x2 is equal to a plus 2h, x3 is equal to a plus 3h, and so on. xn is equal to a plus nh. This xn is the last point, which is b. So this is about the interval, closed interval a comma b is divided into n number of subintervals. From the figure, let us find the area of all the rectangles shapes we get there. If you find area for all rectangles, if you add, we will get the integral a to b f of x dx, as I said, because integral a to b f of x dx is the area bounded by the curves. Okay, so here let's consider the rectangles. Here, when we are considering the rectangles, we are getting an error that triangle is left over. That part we will discuss about that later. So here I said to find the area of triangles, rectangles, what we require, length and breadth we require. So what is length? What is breadth? Let's look into this. So here at the particular point, say for example y is equal to x square plus 2, y is function is defined as x square plus 2. At the point x is equal to 2, you are finding so what you will get, 2 square plus 2, y value becomes 6. So what is y? Here we get 0, 6, which is at the point 2 we get 6. So the 6 is the height of that rectangle at the point x is equal to 2. Same way, if you find the function value at the different points f of x0, is height of that rectangle. F of x1 is height of that rectangle at the point x1. But what is thickness? So the width of the consecutive intervals, if you take that x, it is divided into n number of subintervals. The value is remains the same. Such a way, h is the thickness. How we got? So we defined xn is b, which is a plus nh as b. So that what we are going to get h, so b minus a by n. This is about h thickness. So what is the area of the first rectangle at the point x0? F of x0 into h is the area, and even at the point x1, f of x1 into h, point x2, f of x2 into h, plus and so on, plus f of xn into h, xn minus 1 into h. Here, as I said, here we have the small error. We are leaving this part so that the closed interval a comma b is divided into n number of subintervals. So now what I am doing here means I am going to increase the intervals into equal parts. I am going to divide the n into infinite number of small intervals, so that if you try to understand here, the width of the rectangle becomes thicker and close to the height. Okay, so that we are able to avoid the triangle shape there. So the thickness becomes very close to zero. So if n tends to infinity, which means number of intervals if you increase, infinite number of intervals if you increase, so h tends to 0. So that we can get the rectangles in this way only. All the rectangles will be getting as a small lines only, so that we are able to find all the areas easily if you apply limit. If you take the help of limit n tends to infinity, infinite number of intervals I have divided. So let's replace the function value with the limits. So how I am going to write? Let's write h is common in all the terms. H into f of x0 plus f of x1 plus and so on, plus f of xn minus 1. Here, as I said, limit h tends to 0 as n tends to infinity. So that limit h tends to 0, h into f of x0 plus f of x2 plus and so on f of xn minus 1h. So as we know, xn is equal to b, a plus nh is equal to b. So from this h we get as b minus a by n. Let us replace h by n, so that limit n tends to infinity we get 1 by n h value is b minus a by n. F of x0 is the first point, f of a, f of x0 is the second point, which is a plus h, second point, third point, f of a plus 2h plus and so on, plus a plus f of a plus n minus 1 into h. This is the area of the function f of x integral a to b f of x dx. So this way we get a definite integral of the limit as a sum of a sum. Next we'll look into a problem how we are going to get in this. Simple concept I will take to explain. Integral 1 to 4 f of x dx, let us find. So a function f of x let us define as x. f of x is equal to x. So integral 1 to 4 x dx. So let's compare with as the limit of a sum, definite integral as the limit of a sum, which is b minus a limit n tends to infinity 1 by n f of a plus f of a plus h plus and so on plus f of a plus n minus 1 h. So here integral 1 to 4 x dx is equal to b minus a is upper limit minus lower limit, which is 4 minus 1 will get 3, limit n tends to infinity 1 by n f of a is 1 lower limit plus f of 1 plus h plus f of 1 plus 2h plus and so on plus f of 1 plus n minus 1h. Here 3 limit n tends to infinity 1 by n. F of 1 is what? 1. F of 1 plus is what? 1 plus h. So 1 plus 2h plus and so on plus 1 plus n minus 1h. Here we can observe h is common in all the terms. Here second terms. So we will split the terms. Limit n tends to infinity such a way 1 is added. You observe how many times n is added? 1 is added n times. 1 plus and so on plus 1 plus, here let's add h values now, h plus 2h, and we can observe here h, 2h, h is common, let's write h outside, 1 plus 2 plus 3 plus and so on up to n minus 1th term. 3 limit n tends to infinity, n times we added so that n plus h into n, if you observe all these counting numbers, this is a formula, we know n into n minus 1 by 2, n into n minus 1 by 2, here n is n minus 1, so that n minus 1 into n minus 2 by 2. Yeah, so what is h? Let's replace the value of h now. As I said, xn is equal to b, a plus nh is equal to b. So h is equal to b minus a by n. So what we get? 3 limit n tends to infinity n plus h value b minus a 4 minus 1 by n. 4 minus 1 3 by n. So n into 3 by n into n minus 1 into n minus 2 all divided by 2. So here 1 by n, 1 by n, 1 by n. See, or let's see what's the next step we get. 3 limit n tends to infinity. Let's multiply 1 by n inside, so that n by n plus 3 by n square into n minus 1 into n minus 2 whole divided by 2. Limit n tends to infinity 1 plus 3 by 2 into n minus 1 into n minus 2 by n square. So here we can write 3 into limit n tends to infinity 1 plus 3 by 2 into this we can write as 1 minus 1 by n, 1 minus 2 by n. So if n tends to infinity, this part's 1 by infinity becomes 0, so that we are able to write 3 into 1 plus 3 by 2 into 1, which is 3 into 5 by 2. So if 3 into 5 by 2 is 15 by 2. This is integral 1 to 4 x dx. This way we find the integral, definite integral, as the limit of a sum. Thank you.